Here we have a hypothesis test about a proportion here, and in our problem we've got the governor who believes that more than 55% of the state's registered voters favor casino gambling. To support this claim, the governor's staff conducts a statistical test. The results of the survey show 300 registered voters show that 175 favor casino gambling. Assume a 0.05 significance level for testing. Okay, so what have we got here? We believe our test claim is that more than 55% of the state's registered voters favor casino gambling. Okay, and then so in identifying the hypothesis statement, right, we have to look at a couple of things here. We can reject these ones immediately because they're stated in terms of the sample proportion and not pi, the population proportion. And our hypothesis is that the alternative hypothesis, what we claim or what our research hypothesis is that more than 55% of the population favors casino gambling. So that would be this statement here, and then the alternative, or not the alternative, to complete that and have an all-inclusive set of hypothesis statements, those would be the two right there. So we would say that the status quo, or the null, is that less than or equal to 55% of the population favors casino gambling. The alternative is that more than 55% favor it. Okay, so we've identified that again based on looking at our alternative statement here. We've got an upper tail test. So we've got a rejection region somewhere in the upper tail. The size of that rejection region is 0.05. Okay, or alpha is 0.05. If that were a two-tailed test, we would have to split that in two and say 0.025, the total alpha being 0.05, but all of the rejection region is in the upper tail in our case here. And so the alpha, or the z in this case, because sigma is, or excuse me, not sigma is known, we're using a proportion, so we're using the standard normal based on the rules for that. So z of alpha is then going to be 1.645, and I've just circled that, right? We're splitting the difference between these two, right? We're looking at the closest value to 0.45, right? Which would be from 0 to here is 1.645, and we've got 0.45 here, and we've got 0.05 in the rejection area. Okay, so our decision rule then is that if our test stat is greater than 1.645, reject null, otherwise do not reject. Okay? Again, just saying if it falls in the rejection region, we'll reject the null and say we'll accept the alternative hypothesis, otherwise we will say status quo holds. Okay? Compute the test statistics, so we will use this formula here. So we've got our sample proportion is what? 175 out of 300. Okay, and that is equal to 0.5833. So we have z is going to be 0.5833 minus 0.55, right? And I got the 0.55 from here, right, or our hypothesis statements, either way. And then we divide that by 0.55 times 1 minus 0.55 over 300. Okay, so then our z value for our test sample is 1.1594. Okay, that is less than 1.645, right? So looking at these two, comparing those two, so we are not in the rejection region, therefore we will not reject the null. And based on our answers above, the governor can or cannot claim that 55% of registered voters favor casino gambling. We cannot make that claim. Right? We cannot make that claim. Only if we had fallen into the rejection region could we do that.